Our next speaker is Daryl Porter, who is a solution architect at Kainos Software, where he is also the DevOps capability lead. And he's going to talk to us about how Kainos have used Kubernetes to deploy the NHS app. So, Daryl, it's over with you.
Brilliant. Thanks very much, Peter. Let me just share my screen here and get my video off. Okay, hopefully everyone can see those slides okay. So yes, thanks very much for joining, folks. My name is Daryl Porter. I'm here to talk about the project that I worked on between around May 2018 and the start of this year, which was the NHS app, and specifically talk about how we built that platform on Kubernetes. So before intros or anything else, I wanted to answer the question of why. So why should you listen to the rest of this talk, and why should you be interested? And for me, there are a few reasons that makes the platform that we built quite interesting. The first is because this is a national-facing service across England, which makes the potential user base of over 40 million people, which is quite large scale. We also process medical records and other sensitive information, which made security of paramount importance for us. The platform we built runs active-active across multiple regions, which presented its own challenges. And we have fully automated elastic auto-scaling that can facilitate processing over 150,000 requests per second on demand when it needs to. We also have self-service automation, which allows developers to provision production-like feature test environments in just 42 seconds. And our automation also allows us to provision from a standing start full production service in new regions and new clusters in just 22 minutes. And we'll go through what that process looks like a bit later on. And lastly is that we're an AKS early adopter. So we were one of the first platforms that hosted a production environment on the Azure Kubernetes service in a UK region. So much so that Microsoft actually aligned making AKS generally available in those UK regions, specifically to meet our dates. So quite interesting stuff. But back to introduction. So, and if you saw my video at the start of this talk, you might be thinking I put up the wrong picture here, but that is actually me. So this picture was taken specifically for the Beltec website before lockdown. And before not caring to shave or cutting your own hair was a thing, but I can assure you it is the same person. So like I said before, my name is Daryl Porter, and I'm a solution architect and platform capability or DevOps capability, ops capability lead in Kainos. That goes by many different names. And over my 9 years, I've worked on a number of central government projects across different platform, infrastructure, and DevOps roles. These roles have meant my focus has been on building platforms, both on more traditional VM architectures, then starting to use more PaaS and SaaS solutions before the NHS app became the first time using Kubernetes and Anger to build a production-grade system. And then there's some contact information at the bottom should you want to get in contact after this talk at all. So let's start with a bit of background as to why the NHS app is needed and what it actually does. So the aim for the NHS app was to be the digital front door of the NHS and give access to a number of key functions. It would allow you to check your symptoms and get advice. It would allow you to book and manage GP appointments, order repeat prescriptions, view your medical record, register for organ donation, and manage your data sharing preferences. And providing these services would make the app a critical service across England. And so with that, there were some key requirements that we had to meet from the outset. Like I said before, we're processing medical records and other sensitive information, and so security was of paramount importance. And so one of the specific requirements that we had to meet was to ensure data was encrypted right the way throughout the entire journey, right to the point of code execution. And this would come in to influence our platform decisions later on, ruling out some options where SSL would be terminated at the layer before the code would actually be executed. Like I mentioned already, elastic scalability is another key requirement. So the service would be available to all of England, which made that user base over 40 million people, which meant that there is potential for the demand to be incredibly high. But at the same time, if demand was low, then the platform should scale based on that demand and to be as cost effective as possible. So for example, in times of pandemic, like we're currently in, and there's some new news breaks on the daily update, then the demand is going to be vastly different and vastly higher than what it's going to be at, say, 4 a.m. in the middle of the morning when everyone's in bed because all the bars are closed. Like I said already as well, the NHS app is a critical service, and so it needs to be able to cope with disaster scenarios that could potentially affect the availability of entire regions or data centres. And so another key requirement was to have an active connection across multiple regions. And the final requirement I want to mention was the need to deliver at speed. So towards the end of 2017, the then Health Secretary, Jeremy Hunt, announced that publicly that the NHS would have their own app by the end of the following year in 2018. So this created some pressure for us to deliver, given that the discovery phase for this app finished around, at around May 2018. So delivering at speed was going to be really key to getting the service built and meeting these requirements. So on top of these requirements that were sort of laid out to us, there were two key principles that we wanted to inject ourselves to help meet those goals. The first of which was to adopt a cloud-first approach, but more than that, adopt a platform as a service or software as a service approach also, using PaaS and SaaS options where possible and where appropriate. This would remove the development and management overhead of having to build and manage things yourself when that layer can be offloaded to your cloud provider via PaaS and SaaS options. Doing this allows you to stop having to spend time, effort, and investment on things you just have to do when building a platform, things such as patching and general administration, and instead focus on the higher value add tasks like fine-tuning and auto-scaling, improving your security practices, and improving your release mechanisms, for example. And finally, the second principle was to automate by default. Automation is at the core of everything we do, and it's really key to achieving these requirements, whether that's related to delivering at speed by enabling self-service for developers, ensuring security by removing the potential for manually made misconfigurations, or auto-scaling by enabling Kubernetes native or AKS native features. Automation is really key, and so everything in the platform provisioning or software development lifecycle would be automated by default. Sorry. So the purpose of this talk is to really focus on the platform and Kubernetes side of things. But for context, I'll just give a very brief background of the software side. So another requirement was that the app would need to be available on both Apple and Android app stores. And so it was decided to build a single page web application that we would then surface via native Android and Apple apps. Node.js was adopted for the front-end application, with .NET Core adopted for back-end functions, and this was all built in a microservices architecture pattern. But back to the platform side of things and some key design decisions that were made. So the first was to build on Azure. Azure were a partner of NHS Digital, and so that was quite a simple decision. And the next was to use Kubernetes. So after a review of various different PaaS and SaaS options, Kubernetes was chosen owed to the speed at which it can scale and the more granular control it gives you, which would allow us to meet our security requirement of having to ensure encryption to the point of code execution. We knew that through implementing sidecar Nginx containers alongside application containers in the same pod, that we could terminate the SSL connection within the same boundary, achieving that security goal. And so with using Kubernetes and Azure, the obvious choice was to use Azure's Kubernetes service, which would remove a lot of the development and management overhead of having to build and run your own Kubernetes clusters. Sorry, was someone saying something there? Oh, sorry. So we're deciding to use AKS. AKS at that time was in a private preview, and so we were given early access to that private preview. And then after that, worked closely with Microsoft to align the date. It was made generally available to align with our go-live dates for both single and multi-region. The next important technology decision was Cosmos DB, and more specifically, Azure's Cosmos DB PaaS offering. This would allow us to write session state data to a Cosmos DB instance from multiple regions and share that state across regions with very low latency, enabling us to achieve active-active across multiple regions. And so with these key technologies chosen, let's have a quick look at the high-level design of the platform. So at a very high level, the architecture is very simple. Users enter via an external CDN service, which is publicly accessible on the internet. And we chose an external CDN service at the time simply because Azure's own CDN was not yet available. So if we're doing this again now, that might change. The traffic then enters Azure via Traffic Manager, which routes traffic active-active across multiple regions and targets an ingress controller deployed within the Azure Kubernetes cluster, which we'll see in a slightly more detailed diagram in a few slides' time. All microservices of the application then run within the Kubernetes cluster and use Cosmos DB for sharing session data, like we've already mentioned. All other data for the system regarding medical records or appointment data is hosted by third-party services, and so it's not something that we have to host ourselves. A host of other services are then used, such as Key Vault, Event Hub, and Azure Storage, and Azure's container registry, which is configured to replicate across regions, again, further supporting our multi-region. The next thing I want to talk about is that 22-minute figure that I've mentioned, which is how long it takes to go from having none of this provisioned at all to having a fully running production service. And to achieve that, two technologies were really key for us. The first is Terraform, which allows us to fully automate the provisioning of all our Azure components. And the second is Helm, which allowed us to condense all the Kubernetes resources that the app requires to run, such as ingresses, services, deployments, etc., into one deployable, versionable, promotable, and traceable artifact. And it also allows you to template your Kubernetes configuration and supply variables files to differentiate between dev, test, and production environments, removing the need for any repetitive code. So like I said, these two technologies are key to that 22-minute figure. And so in the next slide, I want to just run through all that's involved in that 22-minute process. So as I mentioned earlier, this is the first time that I had used Kubernetes in anger to really build a production-grade system. And one area of concern that I had was that I didn't have a clear picture of what the CI/CD process would need to look like for a Kubernetes platform. But in reality, it's not too dissimilar to the pipelines that I've been used to on more traditional VM architectures. So you still have some infrastructure elements that need to be provisioned and configured before the app can be hosted. And for us, those are split into common and cluster-specific jobs, which invoke Terraform and Helm deployments via shell scripts that run on TeamCity. You then have some artifacts you'll need to build, which in our case are Docker containers and Helm charts. And you'll then want to deploy these artifacts somewhere to test them before iteratively promoting and deploying these artifacts through environments to ensure that it's the same thing running in production that was tested in those non-production environments earlier in the pipeline. And the only thing that lies outside of this automated process is the releasing of the thin native apps into app stores, and that's given the dependency on app store approvals. The last technical diagram I want to show depicts our Kubernetes deployment pattern, which has evolved over time, and it's one that works really well for us now, and supports hosting multiple versions and releasing new versions with zero downtime. And so I just wanted to highlight a few key areas. The Nginx ingress controller is deployed using an open source Helm chart, and we deploy this in its own namespace, which provides a layer of separation from the application and allows you to restrict traffic flow between namespaces via network policies. Like I mentioned before, our entire application is deployed as a single Helm chart for which we can deploy multiple versions and route traffic between them as required. And the final thing I want to point out is our director at the top there in green. The director is what's key to enabling zero downtime deployments for us. And it's a set of ingress and service resources which we package up and deploy as a chart that controls the routing for the default landing page of the application. It uses pod selectors and labels to target which version to send traffic to, which can be updated without any interruption to service. And if any of this is of interest to you and you want to read a bit more about it, there's a blog on the Kainos website on my Medium account, which I'll flash the details up of again later on. So lastly, I just want to summarize everything we've sort of talked about and summarize why Kubernetes was really key to us building this platform and achieving the goals from the outset. And firstly is that granular control it gives you. So it allows you to customize your security controls. You're also able to deploy clusters on private networks on non-shared compute resources, which in some cases can give it the edge over other native PaaS services. Secondly is the speed at which it can scale. So pods can auto-scale in a small number of seconds, and cluster nodes can auto-scale in just under 5 minutes. So the speed at which your application can scale to demand is incredibly fast, which again may give it an edge over those native PaaS services. And lastly is how well it lends itself to automation, allowing us to create self-service pipelines that allow developers to see features in production-like feature test environments in just 42 seconds, allowing them to iteratively develop and see those iteratively develop those features at a really rapid pace. So that's everything that I had to go through today. I don't know if we have an avenue for questions now or if we can pick them up on the panel later. But other than that, panel, that's perfect. So yeah, other than that, just thank you very much for tuning in, and I look forward to picking up any questions later on.